I'm Anil Kumar. Let me first thank my student Daniel for sharing some good questions on maximum and minimum. And I hope their solutions will help you also. The question here is, a farmer wishes to build 6 chicken pens as shown in the diagram. What is the maximum area that can be fenced in with 600 meters of fence? Well, that's the design. So it's a rectangular thing with 1, 2, 3, 4, 5, 6 pens. Now to answer such questions, we can take one side as the length. So let me say this is the length. So in a rectangle, opposite sides will be same. And these across fences, we'll treat them as widths. So you can notice here we have 3 lengths. So this is my third length. Right? So the fence will be placed like a column horizontally along these lengths and also along these widths. Right? So there are how many widths? There are 4 widths. With this help of these 3 lengths and 4 widths, we can partition and form 6 chicken pens, correct? So that's the situation. Now why some students get confused about it, since the diagram is such that these are not equally placed, so they're trying to figure out how to work out. But it's kind of straight. These lines could be anywhere. Since we are working with the perimeter, it really doesn't matter. Okay, we are given perimeter P equals to 600. Now in this diagram you can see perimeter is these 3 lengths plus 1, 2, 3, 4 widths, right? 4 widths. So that is the perimeter for the given situation. Now we have 2 variables. We should write in terms of one variable. So let me select one. So let's say we use width as the one. So we can write 4W equals to 600 minus 3L, or width equals to 600 divided by 4 minus 3 over 4L, right? So you can write width in terms of length. Okay. Now what is the area? We need to maximize area, right? So the important thing is to maximize area. Area as such is product of length and width. Now since we know width in terms of length, we can write this as length times all this, which is 600 over 4, right? Let's put it in brackets, minus 3 over 4L. Is it okay? So that becomes the area in terms of length. So we have now a function which is in one variable. Now it can be easily solved. To maximize area. How can we maximize area? Now this is a place where many things can be done. To maximize, we could do completing squares method. Okay. Or you could use the factors as such. So I hope you remember completing squares method. It takes a lot of time. So what I will do here is that I will utilize the second method in this particular case, which is utilizing the factors. Now factors is this is a parabola we know. Here you can see this is negative. So if you expand it, you will get minus L square with something, and that will result into a parabola which will be like this, is it okay? So obviously if I have 2 points which are at the same level, then right in the middle I get my maximum. Is it okay? So mid value of those 2. So normally these are your x-intercepts. So this, if you take this along the x-axis, that will be your x-intercept. Here we'll call this length, right? So we'll take L here. Do you understand? So let's find these zeros. Let's find these zeros for the situation, right? Now in this particular situation, when are these zeros? So we are looking for zeros of area A, right? So zeros of area will be 1 when L equals to 0. That's his first one. The other one will be when 600 over 4 is equals to 3 over 4L, right? So now you'll appreciate why I did not really simplify it. I can easily find the value of L from this equation. 4 and 4 cancels, and I have to just divide 600 by 3, right? So 600 by 3 is my length, which is 200. You get an idea, right? So basically what you see here is that the diagram actually results into something like this. That becomes the length and that becomes the area, right? So this is area in terms of length. So we get one intercept, x-intercept at 0, the other one is at 200. Is it okay? So where is the maximum? Midway between them. Do you get an idea, right? So axis of symmetry, we call this as axis of symmetry. So what we have here is axis equals to 0 plus 200 divided by 2, which is 100. So this is that 100 which we are talking about. So we have found the length using this axis of symmetry, right? I hope you appreciate this method, correct? It is very fast. So we did not really do any completing the squares, or we complicated by, expanding, simplifying. With fractions, it becomes kind of tricky. So I hope you appreciate this method. Okay. So now we have the value of L. To find width, what could we do? Just substitute 100 here, right? So what is width equals to? Since we want to find what is the maximum area, so I need to find width also, or need not to find width, we can substitute the value of L here, find area. So you do it like that. Perfect. Substitute here and find it. Okay, but this portion is kind of same as width. Do you see that? So it's one and the same thing. Okay, so I'll calculate width, which is 600 divided by 4. Now you can divide, correct? But let me write 600 divided by 4 minus 3/4 of 100, right? So that is what we have. Let's use calculator. Okay, but this is very easy calculation. 600 divided by 4 is 150 minus 1/4 of 100 is 25 times 3 is 75, correct? That doesn't make sense. So it is 75. So that is how we can actually calculate the width. Once we have length and the width, then we can write down the maximum area, right? What is the maximum area now? Maximum area is length times width, which is 100. 100 is your length times 75. So it is 7500, and the units are meter square. Okay, so that is how you can actually solve this question. I'm Anil Kumar, and I hope that helps. So you should think about this as a normal rectangle. Don't get worried about distances between these sizes. It doesn't really matter. And I hope that works. And try to apply these strategies which I used for finding maximum or minimum. That's the whole idea here. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.